All right, class, now I want to talk about rational exponents. Now, when I say rational, I want you to think of the rational numbers, which are any number that can be represented as a fraction. So this chapter is really about, this section is really about fraction exponents, okay? So I know we get a little freaked out when I use the word fraction, but let me show you that we've already been working with them and that they follow the same exponent rules as whole numbers. So let's take a look at this. We learned in the last two sections that square roots undo squares. So the square root of 7, the square root of 7 squared is going to give us 7. The square root of cube squared is going to give us 3. Okay? Now, 3 and 7 each have an exponent of 1. So essentially what I'm taking is I'm taking 3 squared times something and getting 1. So I want to solve for x, okay? So I have 2 times x equals 1. I divide both sides by 2. I get x equals 1/2. Okay, so if I'm taking the square root, that's the same as raising it to the exponent of 1/2, right? If I had 3 squared to the 1/2, when I'm multiplying, when I have an exponent raised to another exponent, I have to multiply these two numbers. So I'm left with 3 to the first. Essentially, square roots are the exponent of 1/2, and the same is true for all roots. We're going to have different fractional exponents. So, if I'm taking the nth root of a, and it's a real number, then a to the 1 over n equals the n square root of a. Okay? They're interchangeable, is what I'm trying to say here. So 4 to the half is the same as the square root of 4, which is 2. If I have negative 16 to the 1/4, that's the same as the negative 4th root of 16, which would be a negative 2. If I have x to the 1/3, that's the same as taking the cube root of x. If I have 2 to the 1/5, that's the same as taking the 5th root of 2. If I have the cube root of 7, that's the same thing as 7 to the 1/3. Radicals and exponents that are fractions are going to be interchangeable. So let's solve the following. If I want 100 to the 1/2, that's the same as the square root of 100, which is 10. If I have 64 to the 1/3, that's the same as the cube root of 64, which is 4. If I have negative 256 to the 1/4, that's the same as negative 4th root of 256, so negative 4. If I have negative 32 to the 1/5, that's the same as the 5th root of negative 32, which is negative 2. Now, if I have a to the m over n, right, that means I've taken a to the 1 over n, a radical, and brought it to the nth power. So if I have 36 to the 3 over 2, that's the same as taking, our denominator denotes what our radical is going to be. So I'm taking the square root of 36 cubed. I have it written out in 3 steps over here, so let me write it out that way for you guys. All right, this is like saying I have 36 to the 1/2 cubed. Well, now I know that 36 to the 1/2 is the same as the square root of 36 cubed. The square root of 36 is 6, so I'm left with 6 cubed. if I have, and I can leave it in this exponential form, and that's a correct answer, they're equivalent. Okay, let's take a look at problem number 2. If I have 125 to the 2/3 power, that's like saying I have 125 to the 1/3 squared. So I want to find the cube root of 125, which is going to then be squared. The cube root of 125 is 5, so I'm left with 5 squared, which, because I know this one off the top of my head, is 25. But either of these answers would be equivalent. All right, let's take a look at -4 to the 5 halves. This means I have negative, keep that negative on the outside, 4 to the 1/2 raised to the 5th power. So I have negative square root of 4 to the 5th power. Negative square root of 4 is going to give me -2 to the 5th power, which would be -32, because 2 to the 5th is 32. Let's do a couple more examples. If I have -27 to the 2/3, that's like saying I have -27 to the 1/3 squared. Notice this negative was in our parentheses, which is why I brought it with me. So I'm asking for the cube root of -27 squared. Well, the cube root of -27 is going to be a -3, and -3 squared gives me a +9. All right, let's take a look at this example. I have 9 times m to the 5/6. This 5/6 is only attached to my m. So that's like saying I have 9 times m to the 1/6 to the 5th, which is 9 times the 6th root of m to the 5th. If I have 6x to the 2/3, this 2/3 is only attached to my x. So I've got 6 times x to the 1/3 squared, which is 6 times the cube root of x squared. Now, if I have a to the negative m over n, this means 1 over a to the m over n. And this was the same rule we had when I had negative exponents that were whole numbers. So if I had a to the negative w, that would be 1 over aw. Remember, I don't like negative exponents. No negative exponents. So if I have 16 to the -3/4, okay, that's going to give me 1 over 16 to the 3/4. And then I can simplify this. Then I can pull this denominator apart. That gives me 1 over 16 to the 1/4 cubed, which is 1 over the 4th root of 16 cubed. Well, the 4th root of 16 is going to be a 2, because 16 factors into 4 and 4, which gives me 2 and 2 and 2 and 2. So 16 is 2 to the 4th. So I'm left with 1 over 2 cubed, which is 1/8. All right, let's try that again. If I have 25 to the -3 over 2, that's 1 over 25 to the 3/2. That's like saying I have 1 over 25 to the 1/2 cubed. I need to make myself a little bit more room. Equals 1 over the square root of 25 cubed. Well, the square root of 25 is 5. So I have 5 cubed, and 5 cubed is 125. Now, I knew that off the top of my head, but remember, you can leave it in this form, and that's perfectly okay. All right, let's try this again. What if I have 8 to the negative 2/3? 8 over 27 to the negative 2/3. This is a little bit more complicated. Let's work through it. I still have 1 over 8 to the 27th to the 2/3. Okay? So this is like saying I am taking 1 over 8/27 to the 1/3 power squared. So I'm taking the cube root of 8/27 squared. Okay? Remember, when I'm taking the square root or the cube root of fractions, I take the square root of the numerator and the square root of the denominator. Well, here I'm going to take the cube root of the numerator and the cube root of the denominator. That leaves me with 1 over 2/3 squared, which leaves me 1 over 4/9. Now, this is 1 over a fraction, right? Remember, when I have a fraction, that's like I'm dividing. So this is 1 divided by 4/9. To divide fractions, I keep the first fraction the same. I change from division to multiplication, and I flip the second fraction. So my final answer would be 9/4. Okay? I know this is a much harder example, but I got to show you guys these things in case you come across them. Last but not least, let's just rewrite this as a fraction form. So I have 1 over r to the 2/3. That's the same as 1 over r to the 1/3 squared, which is 1 over the cube root of r squared.